we now discuss the problems related to Sylow's theorems that have appeared in the various competitive examinations. We concentrate on questions that are given in the TS SET examination. And these problems are suitable for all the aspirants of JL, DL, TS SET, AP SET and CSIR NET examinations. First, we will review the definitions and the results related to Sylow's theorems. In that direction, the first definition is about Sylow p subgroups. So, we first talk about a p group. Let G be a group, P be a prime number. A group of order p to the power of alpha for some alpha greater than or equal to 1 naturally is a natural number alpha is called a p group. So a group of order p to the power of alpha for some alpha greater than or equal to 1 is called a p group. Subgroups of the p groups are called p subgroups. Subgroups of p groups are called p subgroups. Now comes the definition of Sylow p subgroup. If G is a group of order p to the power of alpha into m, where the prime p does not divide m, then a subgroup of order p to the power of alpha is called a Sylow p subgroup of G. And what a subgroup of order p to the power of alpha in this case is called a Sylow p subgroup of G. Now we have a notation for the number of Sylow p subgroups of G, and it is denoted by n suffix p. So np denotes the number of Sylow p subgroups of G. Right, we are ready to talk about the Sylow's theorems. Let G be a group of order p to the power of alpha multiplied by m, where p is a prime and p does not divide m. Right. The first theorem, Sylow's first theorem says there always exists, in this case, Sylow p subgroup of G always exists. What will be the order of the Sylow p subgroup of G in this case? It is of order p to the power of alpha. So the Sylow's first theorem talks about the existence of Sylow p subgroups. The second Sylow's theorem says the conjugacy of any two Sylow p subgroups of G. So it says any two Sylow p subgroups of G are conjugate in G. The third Sylow's theorem counts the number of Sylow p subgroups of G. So first theorem says the existence, the second theorem says conjugacy, and the third theorem counts the number of Sylow p subgroups of G, that is np, and it is of the form 1 plus kp. That means np is congruent to 1 mod p. Further, this is a very important one. NP divides M. What is M? M is, that factor which is free from, that factor or factors free from P. So NP divides M. This is very important. NP is congruent to 1 mod P and NP divides M. Now comes when a Sylow P subgroup will be a normal subgroup. A Sylow P subgroup of a finite group G is a normal subgroup of G if and only if it is the only Sylow P subgroup of G. That means if NP is equal to 1, then it will be the only Sylow P subgroup of G, then that P Sylow subgroup is normal in G. Right. Now, here comes the definition of a simple group. What is a simple group? A group is a simple if its only normal subgroups are the trivial subgroups, that is the identity subgroup and the group itself. That means a group is simple if it admits non-trivial normal subgroups. Great. So this information, this much results are necessary for us for the discussion of the problems. Let's now discuss this question. This question has appeared in the TS SET 2023 March examination, and it talks about the number of subgroups, and the question number is 70 and with this question ID. The given question is, let G be a simple group of order 216. The order of the group is 216. The number of subgroups of order 27 is, we have to find out the number of subgroups of order 27, and we are given 4 options. Okay, let's now get into the discussion of this problem. We first take the fact that G is a simple group. Yes, it is given to be G is a simple group, and the order of G is given to be 216. The first step is you have to write down its prime factorization. It is 2 cube into 3 cube. Right. Now, what is that we want? Number of subgroups of order 27. That means about 3 cube we have to talk about. So, now 3 cube divides 216, order of G. 3 to the power of 3 plus 1 does not divide order of G. This is the first condition for the existence of the Sylow 3 subgroups. So we apply Sylow's first theorem, then G has Sylow 3 subgroup or subgroups of order 3 cube, that is 27. Because we want 27, therefore we are talking about this one. And now N3, NP, the number of Sylow 3 subgroups of G is of the form 1 plus 3k, that is N3 is congruent to 1 mod 3, and this will give you N3 is congruent to 1 mod 3 will give you N3 is 1 plus 3 4 plus 3 7 plus 3 7 7 plus 3 10, so 1 4 7 10 etc. it goes on. Further, N3 divides that factor or factors which are free from 3, that is 2 cube. That is, further N3 divides 2 cube, that is 8. That is N3 divides 8. N3 divides 8 means N3 is 1 4 only. So these two put together. These two put together. N3 is congruent to 1 mod 3. These are the possibilities. From among this one, N3 divides 8, that is N3 is equal to 1, 4. Suppose that N3 is 1, then G has only one Sylow 3 subgroup, say H, then that subgroup will be normal in G. So, G is admitting a non-trivial normal subgroup of order 27. Therefore, G is not simple, but G is given to be simple. Therefore, it's a contradiction. Therefore, we overrule N3 is equal to 1. Thus, N3 is not equal to 1. Therefore, N3 is 4. N3 is 4. Not N11, it is N3. There is a print mistake. So, the number of Sylow 3 subgroups or the number of subgroups of order 27, then who are the subgroups of order 27? They are the Sylow 3 subgroups. So, they are, so how many number? It will be 4. So, it tallies with our answer given in option 4. So, that is the detailed discussion of the solution of the problem that is given in the TS SET 2023 March examination. Now, let's now move to the next example. This is an example I am editing here because I thought this can be given in a TS SET examination. So, if G is a non-cyclic group of order 57, so you are given a group of order 57 which is not cyclic, then you have to find the number of elements of G of order 3. How many elements of order 3 are there in this group G? So, the 4 options are here. It's an easy question. Given G is not a cyclic group, right? Order of G is given to be 57. The prime factorization is 3 into 19, right? So, we have to talk about the number of elements in G of order 3. So, we take first of all talk about 19. So, by Sylow's first theorem, G has a Sylow 19 subgroup. 19 is a prime of order 19. So, 19 divides 57, 19 squared does not divide 57. Therefore, the first Sylow's theorem applies, and G has a Sylow 19 subgroup of order 19. 19 is a prime, right? By Sylow third theorem, N19, that denotes the number of Sylow 19 subgroup, and it is given by N19 is congruent to 1 mod 19 and N19 divides 3. That factor or the product of factors which is free from 19 is 3. So, these two put together will give you N19 is 1 only, right? So, G has only one Sylow 19 subgroup H, let us say that subgroup as H of order 19, right? What is that we want? The number of elements in G of order 3 we have to find out. Now, let's get into G. What are the orders of the elements of G? Let us ask. Every element of G is of order 1, must be divisors of 57. 1, 3 or 19 or 57 also. But I have not written 57. Why? Because no element of G is of order 57 because G is not cyclic. If G is cyclic, there would have been an element of order 57. It is not cyclic. Therefore, every element of G is of order 1, 3 or 19. Now, every element of G minus H. Now, let's get into G. 19 is a Sylow 19 subgroup. H. In G, there is a H. That is Sylow 19 subgroup. And 19 is prime. And if you see the elements of H, every element other than the identity is of order 19. Because 19 is prime, right? So the every element of G minus H, from G subtract the elements of H, they will be elements of 3 only, elements of 3. So every element of G minus H is of order 3. So what will be the order? So the number of elements in G of order 3 is the order of G minus H, that is order of G minus order of H. Order of G is 57 minus order of H is 19, so that is 38. So the number of elements in G of order 3 is 38. So where is 38? Option 1. So the answer to this question is option 1, and that is the detailed discussion of this example, and it has the potential that it can appear in the ensuing examinations. Right. So let's now move to the next question. So what is that question? This is the question that has appeared in TS SET 2019 examination. It's about the number of subgroups, and this question number is 70. The question ID is given here. Let G be a simple group of order 132. Number of subgroups of order 11 is, we are given 4 options. Right. So we have a group, we have a simple group and its order is 132. Right. We have G is a simple group and order of G is 132 and the prime factorization is 11 into 12. So we have to talk about the number of subgroups of order 11. So we talk about this 11. 11 divides order of G. 11 square does not divide order of G. Therefore, by Sylow's first theorem, it has Sylow 11 subgroups. So 11 divides order of G. 11 square does not divide order of G. So G has Sylow 11 subgroups of order 11 by first Sylow's theorem. So now let's now count how many. N11 stands for the number of Sylow 11 subgroups of G, and it is of the form 1 plus 11k. That is, N11 is congruent to 1 mod 11, and these are the possibilities. And N11 divides 12. That part, or those factors, the product of the factors which are free from 11 is 12. So N11 divides 12. N11 is equal to 1 or 12. These are the only two possibilities. If you take N11 is equal to 1, then G has only one Sylow 11 subgroup, say H, then that will be normal in G. That means G is admitting a non-trivial normal subgroup, thereby G is not simple, but G is given to be simple. A contradiction you will get. Therefore, N11 is not 1. Therefore, N11 is equal to 12. That is the number of Sylow 11 subgroups. And in other words, they are the subgroups of order 11. That is 12. So, where is the answer? The answer is appearing against option 4. Therefore, the answer to this question is option 4. That is the detailed discussion of this question. Let's now move to the next question. This is another example which I am editing, and this also has the potential that it can occur in the state level entrance test. Not CSIR NET, but it can appear in state level test. Now this question reads as the order of any 3 Sylow subgroup of the group G of all 4 by 4 invertible matrices with entries from the field of order 3. So you have G is the group of all 4 by 4 invertible matrices with the entries coming from the field of order 3. And we want to find the order of any 3 Sylow subgroup of this group G. And we have 4 options. That's right. Given G, what is G? The group of 4 by 4 invertible matrices with entries from Z3. Then what it is? Recall. This is equal to GL, general linear group of 4 by 4 non-singular matrices with the entries coming from Z3. That is GL43. And we know we are very familiar. Order of G is order of GL43. What is the order? 3 to the power of 4 minus 1 into 3 to the power of 4 minus 3 into 3 to the power of 4 minus 3 square into 3 to the power of 4 minus 3 cube. Yes. Now, let us take out the 3 common. So, from the first one, 3 is not common. From the second one, 3 is common. From the third factor, 3 square is common. From the fourth factor, 3 cube is common. So, this will be equal to 3 to the power of 6. 3 into 3 square into 3 cube, 3 to the power of 6 into the remaining ones into 80 into 26 into 8 into 2. And 3 does not divide further. So, 3 power 6 divides order of G. 3 to the power of 6 plus 1 does not divide order of G. So, note this one. Therefore, by Sylow's first theorem, G has Sylow 3 subgroup. What is the order of the 3 Sylow subgroup? 3 power 6. That is 729. 729. So, what is the question? What is asked for us? The order of any 3 Sylow subgroup of the group G. So, what is the order of the 3 Sylow subgroup of G? That is 3 power 6. That is 727. Thus, the order of any 3 Sylow subgroup of the group G is 729. The answer is option 4. So, that is the detailed discussion of this question. Now, let's move to the question that has come in CSIR NET 16 September 2022 exam. This is about the number of elements of order 7. And this question bears question ID as 315 under section B. Let G be a simple group of order 168. So, we have a 168 order group, and that is G, and G is given to be simple. How many elements of 7 does it have? We are given 4 options. So, we are given a group G is given to be simple, and it is given its order is 168. Let's now write down prime factorization. It is 2 cube into 3 into 7. We want to talk about how many elements of order 7 does it have. Therefore, we talk 7. So, 7 divides order of G, 7 square does not divide order of G. Therefore, by Sylow's first theorem, G has Sylow 7 subgroup. What is the order of the Sylow 7 subgroup? The order 7. 7. By Sylow's third theorem, we can count the number of Sylow 7 subgroups, and it is given to be n suffix s. And n7 is given to be congruent to 1 mod 7, and n7 divides that factor other than 7 free from 7, that is 2 cube into 3. n7 divides 2 cube into 3, that is n7 is 24. So, this will imply n7 is congruent to 1 mod 7 will give you 1, 8, 15, etc. And from among them, you have to choose n7 divides 24. And that will be n7 is equal to 1, 8. Right. And this talks about if you have, if you get a n7 is 1, then that will be the only Sylow 3 subgroup, and that will become normal. So, if n7 is 1, then it admits a non-trivial normal subgroup, therefore, it is not simple. But it is given to be simple, a contradiction. Therefore, n7 cannot be 1, therefore, n7 is equal to 8. That means there are 8 Sylow 7 subgroups are there. Right. Thus G has 8 Sylow 7 subgroups. We continue for the further discussion. So that's what we have done so far. Let's now remember that we have to find out how many elements of order 7 does G have. Right. Now let H be any Sylow. There are 8 Sylow 7 subgroups. Let H be any one of them. Any one of these Sylow 7 subgroups of order 7. Then H is cyclic. Why? Because it is of order 7. Every group of order 7 is prime. Every group of prime order is cyclic. Therefore, H is cyclic. And further you can see each non-identity element of H is of order 7. Yes. There will be only one element which is of order 1, and all the remaining orders of the elements are 7. Thus H has 6 elements of order 7. You also further source, and every Sylow 7 subgroup of order 7 has 6 elements of order 7. And how many Sylow 7 groups we have? 8 Sylow subgroups. So 8 into 6, that is 48 is our answer. Further you note down that if you have H and K are any two distinct Sylow 7 subgroups of order 7, then the intersection of these two is the identity element alone. So the number of elements of order 7 in G is, there are 8 Sylow 7 subgroups, and each Sylow 7 subgroup has 7 elements of order 7. There are 6 elements of order 7, 6 elements of order 7, 6 elements of order 7. Therefore, 8 into 6, that is equal to 48. So let's look at our options. Our answer 48 appears against option 3. The answer to this question is option 3. That is the detailed discussion of these 5 questions that I have chosen for the discussion of on Sylow's theorems. And these are the questions that have the potential that they can be repeated or they can appear in TS SET examination. Concentrate on Sylow's theorems, and there is a possibility of getting question from that section. So I am sure that you have understood the solutions of these 5 questions on Sylow's theorems, and I have been doing the videos related to the mathematics and related to IIT JEE main examination and CSIR NET mathematics examination. And if you like my videos, I request you, please like, share and subscribe my videos. I wish you all the best. Thank you.